Good morning, students. Welcome you all for a next generation learning. Today, we are going to see the subject physics and class 10, chapter number 11, human eye and colorful world. Topics. The first topic, scattering of light. Second topic, Tyndall effect. Third topic, why is the color of the clear sky blue? Fourth topic, why does the sky appears dark instead of blue to an astronaut? The fifth topic, why traffic signals are red in color? Sixth topic, color of the sun at the sunrise and sunset. Seventh topic, why does the sky appears white at noon? At the last activity. The interplay of light with object around us give rise to several spectacular phenomena in nature. That means, you know that when the light fall on the object, it give us several spectacular phenomena in nature. So what are that? Several spectacular phenomena. One is blue color of the sky, and another one is color of water in deep sea. The third one, the reddening of the sun at sunrise and sunset, or some of the wonderful phenomenon occurs in the sky. When these phenomena occurs in the sky, when the light fall on the object, it gives some spectacular phenomenon in nature. The blue color of the sky, color of water in deep sea, the reddening of the sun at sunrise and sunset. These are the spectacular phenomena in nature. The Earth atmosphere is a heterogeneous mixture of minute particles. You know that if you take a Earth, around Earth, it has atmosphere. This Earth atmosphere consists of heterogeneous mixture of minute particles. In a homogeneous means in a single type of particles are called homogeneous. Heterogeneous means it consists of many type of particles. Example, it includes smoke, tiny water droplet, suspended particles of dust, and molecules of air. So our Earth atmosphere is made up of heterogeneous mixture of particles. In the heterogeneous mixture, it includes smoke, tiny water droplet, suspended particles of dust, and molecules of air. So scattering occurs when light passes through an imperfect medium such as air filled with particles of some sort and are deflected from its straight path. When the scattering will occur? When the light passing through the imperfect medium. The imperfect medium is nothing but it is a heterogeneous mixture of minute particles. So when the light enter into the heterogeneous mixture of this medium, the path of the light ray are deflected. So that is called scattering. Look at this image. Here the sun rays passes through the clouds and the light is deflected of its straight path and scattered in many directions. So this phenomenon and this causes is called scattering of light. It is clearly shown in this image. This is a sun. The sunlight enter into the clouds. So when it enter into the cloud, here the cloud act as an object. This is a light. So here the light and object are interplay with each other. So when the light fall on this cloud, it is scattered, it deflected in it deflected many direction. So this is called scattering of light. When the light is deflected from its straight path, that is called scattering of light. And this scattering of light depends on the two factors. One is size of the suspended particles and another one is wavelength of incident light. You know that when the scattering will happen, when the light fall on the object, this light ray are deflected from its straight path, so it deflected in many directions. This phenomenon is called scattering of light. So this scattering is depends on the two factors. One is the size of the suspended particle and another one is wavelength of the incident light. How the scattering is depends on the size of the suspended particles and wavelength of the incident light. The first one, the size of the suspended particles. If you take an atmosphere, all the particles are suspended only. So the size of the suspended particle is large, scattering of light is more. The size of the suspended particle is small, scattering of light is less. You take our atmosphere consists of many type of particle. It may be large or it may be small. When the light fall on the large size particle, here the more light are scattered. So the scattering is more. When the light fall on the small size particle, the scattering is less. So the scattering depends on the two factors. The one is a suspended of particle. When the particle is a large, the scattering also more. When the particle is small, the scattering is less. It is a very important point. Please note that. The next one, the wavelength of the light. How the scattering is depends upon the wavelength of the light. The sunlight consists of 7 colors. Each color has different wavelength. We already learnt this topic in last class. The sunlight is not a single color. It consists of 7 colors. The 7 colors has different wavelength. And look at this image. This is a wavelength of different colors. And wavelength, you know that if you take a wave, the crest to crest distance is called wavelength or trough to trough distance is called wavelength. So here the red has the longest wavelength comparing to the violet. Because the violet have shortest wavelength, the red has longest wavelength. How this wavelength of light is depends on the scattering. Longest wavelength scattered large size particles, shortest wavelength scattered small size particle. If you take atmosphere, it consists of large size particle and also small size particle. When the sunlight fall on this large size particle, this large size particle scattered only the red color because the sunlight consisting of all color fall on this object. The red color only deflected from its path. The same as when the light fall on the small size particle, this is the sunlight, it consisting of the 7 colors, only the smallest wavelength of violet color only is scattered. And the violet and indigo and blue are called blue family because all the three are the having the shortest wavelength. Violet, indigo, blue are called blue family. So when the light fall on the small size particle, this blue family colors are scattered. So Now you understood that the scattering of light depends on the two factors. One is the size of the suspended particles and another one is wavelength of the light. And the next one is Dendal effect. So what is meant by Dendal effect? Dendal effect is an effect which is created by scattering of light by the particle in its path. Due to the scattering of light, we can see the path of light rays. That is called Tyndall effect. I will explain you. See this example. When a fine beam of sunlight enters a smoke filled room through a small hole, thus scattering of light makes the particles visible. So here, due to the scattering of a light, the particles are visible. When the sunlight passes through the canopy of a dense forest, here tiny water droplet in the mist scatter the light and colloidal solution. Look at this image. Here the boy is standing in a dark room. The dark room consists of many tiny particles. So when a fine beam of sunlight enter into a smoke filled room through a small hole, the scattering of light makes the particle visible. So when the light enter into the room, it hit on the particles. So when the light fall on the particle, it is scattered. Due to that scattering, we can see the particles in that room. So this effect is called Dendal effect. The same as when sunlight passes through a canopy of a dense forest, here tiny water droplet in the mist scatter the light, so we can see the water droplet present in the forest. The next one, colloidal solution. A colloidal solution is a solution where the solute is suspended in the solvent. Look here, there are the two beakers are present. One is a pure water and another one is a colloidal solution. In a colloidal solution, the solute particles are suspended in the solvent. So when the light ray passing through this beaker, we cannot see the light beam in the pure water, but we can see the light beam in colloidal solution. How? Because these suspended particles are scattered the light. Due to that scattering, the light beam is visible to our eye. So this effect is called Dendal effect. The next topic is why color of the sky is blue. Look at this image. So when we look at the sky, the color of the sky is always blue. Why? What is the reason behind this? Before going to see the answer for such a question, you want to know what is meant by electromagnetic spectrum or waves. So the electromagnetic spectrum or waves is nothing but it consists of 7 waves. One is radio wave, microwave, infrared wave, visible light. The visible light is nothing but VIBGR, ultraviolet, the UV rays, X rays and gamma rays. So if you take an electromagnetic spectrum or wave, it consisting of these 7 type of waves. We can see only the visible light. So the visible light have different wavelength. The red has the longest wavelength and violet has shortest wavelength. So earth block and allow EM waves. Fortunately for life on earth, Our atmosphere blocks out high energy radiation like X ray, gamma ray, and UV ray. So, when the electromagnetic wave enter into Earth atmosphere, our Earth atmosphere blocks the high energy X ray, gamma ray, and UV ray. The atmosphere allow visible light, infrared wave, microwave, and radio wave. It blocks X-ray, gamma ray, and UV ray. It allows visible light, infrared wave, microwave, and radio wave. But out of these waves, visible light only visible to our eyes, other waves are invisible. We know that we can see only the light, visible light. We cannot see infrared wave, microwave, and radio wave. But it allow into our Earth atmosphere. So wavelength of the visible light increasing from violet to red. The molecule of air and other fine particle in the atmosphere have size smaller than the wavelength of the visible light. Mostly our atmosphere consisting of more small particles, less large size particles. So when the light enter into the atmosphere, the small particles always scatter the smallest wavelength of blue family light. So these are more effective in scattering of shorter wavelength at the blue end than light of longer wavelength at red end. And dear students, please listen carefully. If you take an atmosphere, this is the earth and this is the atmosphere. The atmosphere consists of more fine particles. In a scattering, you know that the fine particle always scatter the shortest wavelength. That means violet, indigo, blue, the blue family lights. So when the sunlight enter into the earth atmosphere, the blue family of light only scattered. So the sky appears blue. These small particles not scatter the longest wavelength of red. So the sky is not appearing in a red color. Which color is scattered? That color we can see. The red light has a wavelength about 1/8 times greater than the blue light. So when sunlight passes through the atmosphere, the fine particle in air scatter the blue color, that means a shorter wavelength blue color, and more strongly than a red color. So the scattered blue light enters our eyes, so the sky appears blue. This is a very, very important 3 mark. Why the color of the sky is blue? This is the answer. When the sunlight passes through the atmosphere, the fine particles in air scatter the blue color of shorter wavelength more strongly than longer wavelength. So the scattered blue light enters into our eyes. So the color of the sky appears blue. Look at this image. You know that the sunlight consisting of the 7 colors. The 7 colors are entered into our earth atmosphere. Here the blue color only scattered more. So the sky appears blue. All other colors, the longest wavelength of red and yellow and green are not scattered. So the sky is not appear in red, yellow or green color. Here only the blue family of violet, indigo, blue only scattered. So the sky appears blue. In this picture you can see that the blue family of violet, indigo, blue only scattered more comparing to others. Now the second question, why does the sky appears dark instead of blue to an astronaut? You know that this is Earth and this is the Earth atmosphere. So the astronauts are in outer of our atmosphere. So this astronaut peoples are here. If you take in a space, there is no particles. That means vacuum. In atmosphere consisting of air, so this is not vacuum, but a certain height after there is a no atmosphere. That means the space has a vacuum. If there is no particle means when the sunlight enter into that space, there is no scattering. If there is no scattering means the sky appears only in dark. Why does the sky appear so dark instead of blue to an astronaut? Because there is no atmosphere in the outer space. If you go in a long distance, if you reach a certain distance, there is no atmosphere. If there is no atmosphere means there is no particles. If there is no particles means there is no scattering of light taken place. So that the sky appears dark, that means black to astronaut instead of blue. The sky appears dark to passengers flying at a very high altitude. Scattering is not prominent at such heights. The next one, why traffic signals are red in color? You know that if you take a traffic signal, all the traffic signals are red in color. Why? Because the red light is scattered the least by air molecules, fog and smoke. So red is able to travel longest distance. Listen, you know that if you take our earth atmosphere, the earth atmosphere consisting of small size particles only. So when the light fall on the small size particles, shorter wavelengths are scattered. But the longest wavelength of red light is least scattered and it can travel for the longest distance. So that reasons the traffic signals are red in color. Because when you are in a signal, you can, maybe you are in a long distance than the signal area, but you can see whether they're putting signals or not. How? Because due to the red light is least scattered, it can travel through a long distance, so that we can see the red light if you are in a longer distance. This is also very important question. Study it. The next one, have you seen the sky and the sun at sunrise or sunset? Look at this image. These two images, this is a sunrise and this is a sunset. During the sunrise and the sunset, the color of the sky is red instead of blue. Why? What is the reason? Because this is our earth, this is a horizon line. You are here. During sunrise, the sun is below the horizon. So the sunlight has to travel longer distance to reach our eyes. And this is the earth atmosphere. The earth atmosphere consisting of many small size particles. So when the sunlight enter into the earth atmosphere, the small size particles are scattered the blue light. The longest wavelength of red only travel a longer distance and reach eye. So during the sunrise, the sky appears red. the same as sunset also. During sunset, the sun is below the horizon. This is a horizon line. This is a earth. You are here. So during the sunset, the sunlight has to travel longer distance to reach our eyes. So it can cross the atmosphere. The atmosphere consisting of the small size particle. The small size particles scatter the blue family. So the red light only least scattered and reach the our eyes. So during the sunset, the sky appears red. Light from the sun near the horizon passes through the thick layer of air and a larger distance in earth atmosphere before reaching our eye. See here. You are here. This is a earth. This is a larger distance to reach our eye. Near the horizon, most of the blue light and the shorter wavelength are scattered away by particles. Yeah, already I said that blue light and shorter wavelength are scattered away. The light that reaches our eye is a longer wavelength, so this gives rise to a reddish appearance of the sun. Why does the sky appears white at noon? During the noon time, the distance between the observer and the sun is very less comparing to the sunrise and sunset. Because sunrise and sunset, the light has to travel larger distance. At noon time, the light has to travel a smaller distance. When the sun is overhead, as at noon, the light coming from the sun has to travel shorter distance through the atmosphere to reach us. At noon, the sun appears white as only the blue light and violet colors are scattered. So you know that when the light enter into the atmosphere, it consisting of the 7 colors. Only the small amount of blue and violet light only scattered. So all other colors are combined and gives us white color. So during the noon time, the sun appears white. Or you understand why the sun appears white at the noon time? Listen, the sunlight means it consisting of 7 colors. The 7 colors also enter into our earth atmosphere. Only the small amount of blue and violet scattered. So this red combined and all other colors are combined. Here the violet and blue also combined. Only small amount of blue and violet are scattered. When these 7 colors are combined, it gives white color. So during the noon time, the sky appears white because of least scattered by the violet and blue. So this is an activity. From this activity, we can understood why the color of the sky is blue and why the sun appears red color during sunrise, why the sky appears red in color during the sunrise and sunset. For doing this activity, I have took one convex lens and light source and water tank and cardboard sheet with slit, one more convex lens and a screen. For doing this activity, I took water in the tank and this is a light source. When the light source enter into convex lens, it converges all the light rays and all the light rays are passing through this water tank and it come out from this water tank and enter into the cardboard slit. Again it goes into convex lens. This lens converges all the light rays. It forms the color on the screen. So which color is the form on the screen? We will see that. Look here, place a strong source of white light at the focus of converging lens. This lens provides a parallel beam of light. Why we are keeping the convex lens here? Because it converges the light rays and give a parallel beam of light rays. Allow the light beam to pass through the transparent glass tank. It is a transparent glass tank containing clear water. Then allow the beam of light to pass through the circular coil made in cardboard and obtain a sharp image of the circular coil on your screen using the second converging lens. So when the light passing through the first converging lens, at the last the light is we are obtaining the light on the screen. So during that time you have to take a 200 gram of sodium thiosulfate and add concentrate sulfuric acid into the water tank. So in a water tank you have to dissolve 200 gram of sodium thiosulfate in about 2 liter of clean water taken in the tank and add 1 to 2 ml of concentrated sulfuric acid to the water. Why we are adding this to here? So here the suspended particles, the sodium thiosulfate suspended particles are present in the water tank. So when the light passing through this water tank, here the sodium thiosulfate particles are scatter the shorter wavelength. So that this tank appears blue. It does not scatter the longest wavelength of red. So the longest wavelength of red reach the screen. So from this we can understand that the small size particles always scatter the blue light and large size particles, the small size particles scatter only the blue light, so the sky appears blue. The longest wavelength of red light does not scattered by the particles, so it can travel for the longer distance. These activities demonstrate that scattering of light that help you to understand bluish color of the sky and the reddish appearance of the sun at the sunrise and the sunset. Uh, you know that during noon time the light has to travel the smaller distance. During the sunrise and sunset the light has to travel the longest distance. So when the light travel to the longest distance, the red only reach our eyes, the blue light was scattered. I hope you understood. Thank you for watching.